Login accepted.
Hi, everyone. Hello. Thank you for joining me. I know I'm the last person standing between you and the cold beer, so let's try to do this quick. I'll try to make it light. I'm not going to show any code in the snippets. That's not the goal. Well, there is some YAML files, but that's not code, technically. How many people are here because they read the title of the talk and they found it provoking? Raise your hand. Awesome. I did a good job. Good. Nice. So the talk title on the agenda is a little bit different. It's called Why You Shouldn't Use a Service Mesh. I changed it. You probably don't need a service mesh, but it's kind of the same idea. So I'm going to talk about the why not of a service mesh. But before I do that, I realized that not everybody knows probably what a service mesh is. And I realized also that there have been a lot of talks in the conference talking about service mesh, but more from a specific programming language or framework. So I'm going to give you like a historical trip into where did we came from to actually today talking about service mesh and why do we even talk about it. And then I'm going to tell you why you shouldn't use it. And the why you shouldn't use it is my distilled experience of 5 years working on service mesh implementations since Istio version 1.0. So I started with that when I joined the consulting part of Google Cloud. I'm now a developer advocate. And I basically wrote this article on my Medium blog post, and I am doing it in the form of a talk. So I'm going to talk about the why nots. But it's more like, it's not really why not, why you shouldn't use the service mesh. It's more what you should consider before you commit to using a service mesh. But before we get there, let's talk about what is a service mesh. And before we can do that, we talk about where we came from. So we used to do monoliths, and they were cool at some point. And then at some point, they were not cool anymore, because we decided they're not cool anymore, right? That's just how the industry works. And we try to fix them by just adding APIs to them. How many people have done XML RPC before? Oh, 2 people. I feel old. So then we sort of moved to REST and gRPC and all the fancy stuff we do right now. And we introduced a few years back this concept of API gateways, which is basically wrapping a monolith in something that looks modern, but it's not. It's just a bad idea. And then at some point, every single developer have decided that I'm going to rewrite everything from scratch, right? Because that's what developers do. They want to just rewrite everything from scratch. And that's fine. So we came up with this idea of microservices, which is take an application, split it into small chunks. Microservices are better because they allow you to release faster. They allow you to decouple your application into business logic. And they allow you to automate better, right? These are all the cool stuff that microservices are good for. Containers showed up 2015 with Docker specifically. Containers existed, by the way, in Linux a long time ago. Docker just made them easier and made it such a way that you don't have to learn what namespace and what C groups are. And people started adopting containers, and today we just assume that containers are the thing, right? Like everybody just talks about containers like it's the de facto way of writing and distributing software. But we have been doing things differently for a very long time. And containers have a lot of good things. They are fast, they are lightweight, they are easy to share, they allow you to bin pack your application with all its dependencies and just put it on a machine and quickly start it, stop it, debug it, whatever. But running containers at scale is not easy, right? If running 2 or 3 containers with something like Docker Compose is pretty easy, maybe even 10 or 20. Running thousands of containers in a microservice-based environments at the scale of a regular e-commerce company is not easy, right? They have a lot of problems, like how do you find them, how do you debug them, how do you collect logs and metrics, et cetera, et cetera. And at some point, 2015, a bunch of very smart people at Google came up with this idea, let's build something called Kubernetes, which is inspired by Borg, our internal orchestration or container orchestration system. So it was built in 2015 and released, and it's getting a wide adoption. I don't know if you heard about this, but there is a large conference called KubeCon that takes place every year, 3 times a year, and it gets about 20,000 people each time. So it's a very popular tool. Like a lot of people use it, a lot of people adopt it. It allows you to run containers at scale. The easiest way to think about Kubernetes, if you haven't really never thought about it, it allows you to take a bunch of nodes. They could be virtual machines or physical machines or Raspberry Pis or laptops or whatever. and treat them as if they were one big computer. And you just send your stuff that you want to schedule to Kubernetes, and Kubernetes will figure out where to put it, how to run it, and how to make you connect to it, right? It runs everywhere, it runs on all operating systems, and it just works. But then again, the problem is that each time we introduce an abstraction layer away from the infrastructure, we introduce a bunch of problems. And we have to solve these problems somehow. Kubernetes itself is not a solution. It's a great tool. It does introduce a lot of new problems that you have to deal with, right? Let's take one simple example. Let's say you have two containers. They can be pods or containers or VMs or whatever. And you want them to talk to each other. That's easy to do. You expose one container on one port. You make the other container to talk to the first container on that specific port. Now, let's say that your security guys come and say, we want to add MTLS. MTLS is mutual TLS. It's basically TLS on steroids. TLS is where the client verifies the identity of the server. Mutual TLS is where the server can also verify the identity of the client, right? That's MTLS. Doing MTLS between two containers, the two applications, is easy. You can just mount certificates on both sides, use some sort of library in your programming language, do some TLS, encrypt traffic, send it to the other side, happy days. Doing it at scale is a problem. If you have thousands and thousands of containers and you want to do MTLS, then some of the issues you will have to deal with are how do you rotate the certificate? How do you revoke them in case they get exposed? What if somebody steals your private key that you used to sign all the certificates? Well, suddenly you have to rotate everything, change the private key, generate new certificates, et cetera, et cetera. Doing that at scale is not easy. Doing it manually at scale, at least, is not easy. That's why some people decided that we need actually a control plane. We need a central place that we can use to issue certificates and that we can use to distribute certificates to workloads. And all these workloads will just talk to the central place and say, hey, give me a certificate. And then every single time one service needs to talk to another service, and they need to verify the identity of that service, they can talk to a control plane, and that's where a CA runs, a certificate authority. That's how they can verify the identity of that. They can verify the validity of the certificate, right? And then with that idea, people started thinking, well, what if we can add all sorts of policy management in that central place? Since we have a central place to do certificate management, we can also make it do other stuff. We can make it do routing, like if you want to do a canary deployment. We can have a control plane, configure our container-based infrastructure to do 95% traffic to the new version of the app, right? We can make it enforce policies, right? If that control plane can look at the traffic, we can make it also intercept the traffic, and we can make it enforce policies, do authorization, do authentication, do a bunch of things. And since we have traffic going through a control plane, we can also do telemetry. We can collect a bunch of metrics, right? So yeah, all sorts of policies can be done in a central place. I'm not describing rocket science here, just a concept of control plane and data plane, which existed since a long time ago. So like one of the first technically implementation of service mesh was using what we call proxy libraries. So a lot of programming languages have a lot of libraries that you can use to basically offload all this policy management, all this certificate management to a control plane. The whole idea of a proxy library is that when your application boots up, it dials in, it connects to a control plane, to an endpoint, and the endpoint tells it what to do. And then the proxy will be sitting, the library will be sitting at the edge of the application, listening to all the traffic coming in and exiting the application, and implementing all sorts of policies on it, right? And then the service mesh concept came into existence. The idea of a service mesh is that your proxy is not a library anymore. It's an actual proxy. It's a software. It's a container, a binary, an app, whatever, that sits in the path between your application and all its dependencies. So the proxies are the central place where all the certificate management and policies are enforced. These proxies are configured using a control plane. The control plane is what you use as an operator to configure the service mesh, right? So this is kind of the idea. And that's how one of the most popular service mesh tools, Istio, was created. By the way, most of this talk is actually focused on Istio. I know that some people in the audience might come to me later and say, like, but that's not how it works in Cilium. I understand. That's not the point. Istio have been the first. People have been implementing it for the longest so far. I haven't seen any large-scale implementation with other service tools yet, and I did look very heavily. So we're going to focus on Istio. And all the experiences I have that I want to share with you are actually focused on Istio. Now, some service mesh does things differently, which means some of the problems that I'm going to talk about might not exist. It doesn't mean that they're not relevant, right? So how does Istio works? In an Istio world, you have a control plane, which is Istio-D. It's just a container. That Istio-D can run on Kubernetes. You configure it using YAML files as a user. And that Istio-D distributes configurations and certificates to a proxy layer, which in the Istio world, that proxy layer is Envoy. So Envoy is an open source C++ proxy that have been developed by Lyft a long time ago. And Istio and Envoy have been made to work together. Why Envoy specifically, and why was it the choice when Istio was created? Very simply because Envoy is a proxy you can configure with an API. It does not need files to be configured. Most proxies that exist at the time, like HA proxy, you need to write configuration in a file, and you need to reload the proxy to read this configuration. Istio can be configured and reconfigured on the spot using an API, right? And Istio is an API-driven control plane. The way Istio works is that once your application starts, the proxy container will start before. It will connect to the control plane, and it will tell the control plane, give me the configuration. The control plane will give it some certificates, a bunch of policies to enforce. Then your application starts. Then all the traffic going from your application in and out, both ways, goes through the proxy. The proxy intercepts all the traffic, enforces all the policies, add encryption, and then send traffic to the other proxy on the other end, which will remove the encryption, enforce more policies, and then send traffic to your application. So your application can use HTTP or gRPC. It doesn't have to use TLS. It doesn't care if TLS exists. It just knows that there is something on the path that will enforce TLS, right? That's a service mesh in a nutshell. What I said earlier about the fact that some service mesh tools does this differently, some variation could be that the proxy is not per container, it's per node. So what I'm showing here is the cases where your proxy is per container. Every single container in your microservice environment have a proxy running along it, right? Tools like Cilium, what they do is that they do a proxy at the node level. So all the containers on the node uses the same proxy at the node level to enforce all the policies, do TLS, et cetera, et cetera. That doesn't make it better. It creates a set of new problems, and we can talk about that. But essentially, most service mesh architectures works this way. There is a control plane, there is a data plane, there is a proxy layer that enforces policies, right? By the way, I want this to be interactive. If you have questions, just raise your hand. And if I am saying bullshit, tell me.
What is the data plane in this case?
The Envoy proxies. So the control plane is the part that configures the proxies. The data plane is the Envoy proxies. Because that's where the data travels through, right? Yes? Yeah? In an Istio world, yes. So in an Istio world, the gray box is a pod. The rectangles inside are containers, right? In Kubernetes, you can have one pod that runs multiple containers. That's what we call the sidecar pattern, right? So in the context of Kubernetes, the pod will have your application container, and it will have a sidecar, which is Envoy, right? And the way it works technically is that if you deploy Istio on a service mesh, if you deploy Istio on a Kubernetes installation, and you start a bunch of pods with the sidecars, you can actually intercept or inspect the YAML file, the definition of a pod, and you will see that there are technically 3 containers. There is your application, there is the sidecar, which is a container, and there is an init container, which starts and does a bunch of things at the beginning. And what the init container does, it writes into the namespace configuration of the pod a bunch of IP table rules that will forward the traffic coming from the container of your application to localhost 15,200. So that's the port on which Envoy listens, right? It basically forces traffic through the proxy. That's essentially what it does. No worries.
So there is no TLS between service and proxy?
Very good question. No. Between the application itself and the proxy, there is no TLS. So your application doesn't have to care about TLS. It just talks HTTP, and the proxy intercepts the traffic and add the TLS stuff to it. Does that answer your question?
Yes. But if they, let's say, security want to enforce TLS between those services, which are probably in some VCP, some virtual, let's say, network, they still probably tell me, okay,
That's a very good question you are bringing. So if we're talking about the Istio, the context of Istio, the container, which is your application, and the proxy run inside the pod. So it's inside the same container, right? So they are fairly close to each other, and they talk to each other on localhost. So intercepting the traffic between the service and the proxy in the context of Istio is pretty hard. It's pretty complex to do. Now, some implementations that I talked about, like Cilium, because the proxy is at the node level, that's a very valid question. Because if the proxy is at the node and all the container uses the same proxy, what if that proxy is compromised? And what if another container can start and intercept all the traffic going between the containers and the proxy, right? And Cilium will tell you that they have a solution for it. They don't. It's just that moving the proxy down to the node solves certain problems, but introduces another set of problems, right? Like everything in life, exactly. That's why we have a job. So, Istio as well have this concept of ingress gateway and egress gateways. I don't want to spend too much time on those, but roughly what they do, an ingress gateway is an API at the edge of the mesh that you will use to expose stuff to the internet. An egress gateway works the other way around. So if your containers need to talk to a third-party API, you can force traffic to go through an egress gateway, and you can also enforce a bunch of policies at the egress gateway. For example, you can do JOT token validation at the ingress or at the egress. You can add a TLS certificate before traffic leaves the mesh, and you can do a bunch of things, right? So that's Istio configuration architecture in a nutshell. Yes? Is there any certificate validation between? Yes. So the Istio control plane has a CA built in, a certificate authority, and so are you talking about between the proxy and the control plane? Yeah. Yes. So it uses the built-in CA to verify the identity. So even the communication between the envoy proxy and the control plane is encrypted with TLS, right? Oh, it's encrypted with MTLS technically. Envoy is the little thing that says proxy. That's the logo of Envoy. Sorry, I should have written Envoy. I just assumed everybody knows it from the logo. But yeah, the little rectangle with the little logo, that's Envoy. And so once you have this in place, you can do a bunch of other things with traffic. Traffic splitting is a popular one. You can say, I have service A, I have service B. I'm bringing up a new version of service B, and I want to do 5% of the traffic to service B, and then 95% traffic to service version 2, and then 95% to version 1. So that's something you can do actually with service mesh. Most service mesh tools have this kind of traffic management capabilities. By the way, if you have never thought about why we call it a service mesh, look at the arrows. The arrows indicate that in a service mesh context, there is no load balancers. Communication between services is actually between proxies. And that's one of the reasons why we call it a mesh, because every single proxy knows where every other proxy is. Every proxy has a full routing table of the IP addresses of all the other proxies, and that's why we call it a mesh, because things talk to each other directly without load balancers in the middle, right? Now, to recap, service mesh could have a bunch of benefits. They allow you to connect and control the flow between applications, so you can do things like routing, header rewrites. You can do even header-based routing policies. You can say, if users are coming from an iPhone, send them to this version. If they're coming from Android, send them to this other version. If they're coming from Firefox, send them here. If they're coming from Chrome, send them here, etc. You can secure service communication, so you can do encryption. You can do even authorization and authentication. You can control who can talk to what. And then you can observe by collecting a bunch of metrics from the invoice, because all traffic go through the sidecar. The sidecar can give you a bunch of metrics, basically to monitor your service mesh, right? So those are the benefits. Now let's talk about the problems or the drawbacks. I have done service mesh implementations for a while, and I came to the conclusion that there are 4 main overlooked things that people forget to think about, decide on, and architect around when they decide to use service mesh. One is capacity and resources. How much is your service mesh data plane going to consume matters, because those are proxies. There is a proxy everywhere. And proxies, you need memory and CPU, right? Second one is latency. Once you add a proxy in the middle of traffic, you add latency. There is no way around it. Third is designing and architecting. there are a bunch of design decisions, especially if you're running on cloud, that you have to make from day one, and that if you don't and you want to change them later, it means you have to rewrite and recreate everything, right? And the fourth one is what I call auxiliary infrastructure. All the stuff that you need to run on the side to take full advantage of what the service mesh gives you. And we're going to go through these one by one. Let's talk about capacity and resource. This is actually the last results from Istio 1.14. It's the last version of Istio. They do a performance testing for every version, and they share the results. This is the one from the last version. And basically, they ran a load test on 1,000 services with 2,000 sidecars and 70,000 RPS, so 70,000 requests per second. And they realized that every single proxy consumes 0.35 virtual CPU and 40 megabytes per 1,000 requests per second. And that Istio-D itself, the control plane, uses 1 vCPU and 1.5 gigabytes of memory. Now, put this way, might not sound like a lot. But this is 0.35 vCPU and 40 megabytes of memory per envoy. If you're running 1,000 containers, you should multiply the two numbers by 1,000, because every single container has a proxy, right? This actually could be a problem if you are trying to run an application and you do some rough capacity planning and you realize, well, my application needs 1 CPU and 2 gigabytes of memory. And then you just add the service mesh to it. And now each application needs 1.5 vCPU and an extra 40 megabytes of memory, which is for 1,000, that's quite a lot of memory that you have to pay for, right? Some implementations of service mesh does not have this problem because they probably have less proxies. But it doesn't mean that they don't have the problem. They still have proxies, right? If we take an example of Cilium, which I talked about earlier, what they have done with the new Cilium service mesh, they just announced it in Valencia, KubeCon Valencia. I don't know if you were at KubeCon Valencia this year in May. Cilium announced their service mesh, right? And they said, OK, it's different. It's better than Istio because this is how it works. There is an envoy in each node. And that envoy will be responsible for intercepting the traffic for all the containers running on the node, right? I haven't looked into the numbers, but my argument would be, if you are moving all your traffic management to a single point, that single point, which is a proxy, will need resources to handle all the communication from all the containers on the node. And the more containers exist on the node, the bigger that envoy needs to be, or the more replicas you have to run, right? So there is my point here I'm trying to make is that there is a significant amount of resources that the data plane of a service mesh needs that you need to account for, right? Very good question. Very good point. What kind of load balancers are we talking about? Right? Are they virtual load balancers or are they actually physical load balancers? Because if you talk about a cloud environment, most load balancers in cloud are virtual, right? And most of them, they charge you for the network traffic going through them. They don't charge you for how much the load balancer itself needs, for how much resources the load balancer needs, right? Does that make sense? I don't know neither. I don't know the answer from the top of my head, but you don't. So when you are planning to use a virtual or a cloud-based load balancer, you don't have to take that into your capacity planning. That's the point. Because it's not your problem. It's a managed service, right? You just provision load balancer. It sits there between your application. Maybe it has limitations in terms of how much network throughput you can push through it, but that's none of your problems. When you do a service mesh, you have to pay for these resources. The service mesh resources, or the resources consumed by the service mesh components, the data plane and control plane, are your problem. You have to plan for them. Does this make sense? All right, so that's when it comes into capacity and resources. Network latency, because proxies, right? Proxies means latency. So again, taking just Istio, because they do have, in my opinion, Istio has some of the most accurate, up-to-date, best, performance test results, because they do them automatically for every single version. And again, using the last version, using the same. By the way, where I got this information from, you will find it in the notes doc in the slides. So if you use a service mesh with Istio, for example, 114, you are adding about 1.7 milliseconds to 2.7 milliseconds at the 90 and 99 percentile per container, per communication, basically, right? Because you have proxies in the middle, and those proxies need to do things. They need to remove TLS certificates. They need to enforce some policies. So they will take some time, right? Now, 1.7 milliseconds and 2.7 milliseconds might not be a lot. Depends on your application, depends on your use case. It's latency that you have to account for, right? So latency, to me, when it comes into service mesh implementations, is actually the lowest level of problems because it's always a trade-off. Do you accept few latencies in exchange for being able to do security and MTLS out of the box? Maybe the answer is yes. If your application is latency sensitive, this could be a problem.
Did you have a test with MTLS, but without the proxy?
With MTLS without the proxy. So you want to implement your own MTLS.
So yeah, I'm saying that basically what I'm thinking is that part of this latency is actually, as you pointed out, MTLS calculations, like adding certificates, validating, and so on.
Yes.
And basically, if you are enforced to have secure traffic, probably the proxy is not a lot of overhead. The proxy itself.
Yeah, not a lot of overhead in terms of how much resources it consumes or how much latency it introduces.
How much latency it introduces, maybe it's like the calculation itself on MTLS, which introduces this latency. This is what I'm asking. Do you know if this is basically this part or this is network part?
No, so this is latency with MTLS enabled.
I know. Did you, like, you tested basically Envoy and MTLS, right?
Yes,
So if I implement MTLS myself,
I see.
without Envoy, I will still consume some more resources, so I feel we'll have a little bit of more latency, right?
Yes, or less. It depends. Well, we don't know. Or less. Yes.
Exactly. This is my point. And if by company policy I'm enforced to have MTLS, let's say, that means that theoretically the Envoy itself might not add overhead at all.
Yeah, it could be, yes. Yeah. So I haven't, okay, to answer your question, I haven't tested this myself. So I haven't done a benchmark to see if I would implement MTLS myself in the app versus if I would do it with Envoy, how much of a difference it will be. I would assume there will be some latency because, you know, MTLS. Basically, MTLS or TLS is the same concept. You have a handshake, right? So you have to, and with MTLS, you are doing the handshake twice because the clients have to present the certificates, the server have to talk to the CA, validate the certificates, then it has to answer with its own certificates, then the client has to talk to the CA, validate the certificates before the traffic starts flowing, right? So doing this with your own libraries could introduce maybe less latency than this, or more. It depends on the application, it depends on the framework you are using, it depends on the programming language. I don't know the answer to that question specifically. All right. The third one is designing an architecture. And this is a very random picture that might not mean much, but let me explain. One of the key features of service mesh is this concept of logical service mesh. Basically, what you're seeing here is a single service mesh spans across three Kubernetes clusters in 3 regions. So you can have 3 Kubernetes clusters, 6 Kubernetes clusters, 12 Kubernetes clusters, doesn't matter, that are located in different parts of the world, and then you can connect them together such a way that you have one big logical service mesh, right? What does that actually mean? It means that, let's say, for example, we are building an application to sell the FIFA World Cup tickets in Qatar, right? We need that to be global. We need the application to be available everywhere because people are going to buy tickets from everywhere, right? So we might decide we're going to run this application, and we're going to run it on a cluster in each of the regions where we're serving traffic to reduce latency, et cetera, et cetera. And what we're going to do is we're going to run the same exact application everywhere. So we'll have the same copy of the application per region. And each region, most of the time, will be independent, isolated, which means microservices in Japan will talk only to microservices in Japan, US to US, Europe to Europe, right? With a logical service mesh, one of the things you can do is if you are taking down, if you are updating a microservice, if you're introducing a new version of a microservice, you can do a local rollout. What that it means is that you can go to the cluster in Japan and take down one microservice. And because you have one big logical service mesh, the services in Japan that will depend on that microservice you removed will be able to flow over to the US and talk to the microservice in the US. because it's one big, large service mesh, right? That's the whole concept of a logical service mesh, right? This is a great thing to have, and a lot of companies will want to have that. The problem here is, if you want to design this on cloud, and you are using something like a VPC, which, the global network thing that all cloud providers have, well, you will have to decide on day one if you want to architect like this, or if you want to architect around one service mesh per region. Because once you do one global service mesh, you can't actually change it. And changing it will mean you have to destroy everything and create them again. Because most cloud providers allow you to do certain things only once. You can create a Kubernetes cluster only once, but you cannot change it. You cannot edit it, you cannot add networks, you cannot change the network IP address range, you cannot do a bunch of things, right? You can only do, I don't know, route configuration in the VPC once. You can only configure all your VPC routing when you create the VPC. You cannot change it later. So all this decision around, am I going to do a global service mesh? Am I going to do a local service mesh? If I do a local service mesh, how are things going to communicate with each other when one of the clusters is down, or when one of the regions is down, or when the cloud is down in that region, whatever? These are decisions you have to make on day one. You can certain things around how you architect for a service mesh cannot be changed later. I think even Istio actually does not allow you to go from one service mesh per region to a global service mesh out of the box, right? Because the way you deploy Istio for a single cluster service mesh or for a multi-cluster service mesh is different, and you cannot change it, right? So these are one of the other considerations I would talk about. And last but not least, and I want to open up the floor for questions, is I like to use this word to say a service mesh does not live in vacuum. What does that mean? A service mesh gives you a bunch of features that we talked about. It gives you a lot of metrics that you can take advantage of. It can give you tracing. It can give you graphs. It can give you a lot of things. But in order to take advantage of all the stuff that the service mesh gives you, you need to install extra software. So you need Prometheus and Grafana in order to collect metrics and logs. Well, metrics. You need Kiali if you want to do graph visualization. If you want to install, run your application, and then see the dependencies between application, see where you are missing encryption, etc., in a visual way. You have to install Jaeger if you have OpenTelemetry and if you're doing tracing, right? So if you're doing tracing inside the microservice environment to trace where the request goes through, which microservice might be a point of failure, etc., you need Jaeger. But these softwares need to be installed and maintained. They consume resources, they consume engineering time, so you have to take into account that when you deploy Istio, it's not just Istio and Kubernetes, it's also a hell of a lot of ecosystem software around it that you have to take into account. So the why not of service mesh, and this is my closing notes. A, don't take a simplistic approach. Most of the service mesh implementations I've seen are, it does MTLS, good, let's use it, because security said so. No, that's the wrong approach. The right approach is that you have to look into what the service mesh actually gives you in terms of features, so you don't end up having a service mesh that gives you a bunch of features, but you still implement them in the code because you don't know how to use these features. And B, and also you have to take into account the footprint, so the resources I talked about. How much is this thing going to consume, and how much is going to cost at the end of the month, right? It will increase your technical depth, that's for sure, because you're running an extra layer of abstraction. You're running extra software. It's complex. It will make it harder. And it will increase your operational complexity, because now you have a proxy in the middle that you need to debug. And you need to figure out when things doesn't work, why they don't work. I have written my article on Medium. You can read more details. I have shared actually a bunch of more details with some performance testing and snapshots and stuff like that. So feel free to read it when you have time. And with that, thank you very much. I hope it was useful. I'm open for questions. Yes? No, we don't. No, we don't. We don't, because we had something before. We have our own internal authentication and authorization and TLS encryption software that we used to have for a while, and we didn't change it. Yeah, so we have a managed version called ISM, Anthos Service Mesh. And we have actually two managed versions. There is something called Traffic Director, and there is service mesh with Anthos, and they're both managed. One of them is, so if you use Anthos service mesh, it's just Istio. So it's open source Istio, but supported by us. And you can choose to have fully managed, where you have to manage the control plane and the data plane, or we can only manage the control plane, or you can just run everything yourself. So you use our software. Traffic Director is the same concept, it's still service mesh, but the way you configure it, it does not use the Istio API, it uses a proprietary API. It's not based on open source, correct, yes, it's fully proprietary. It's the same concepts, but just the way you configure it, the way you use it, the kind of visibility you have is different than Istio. No, there is no feature parity, there are two different products. No worries. Any other questions? Yes? Yes, you could, technically, but it's actually was designed to run on Kubernetes. You could do something, what you could do is you could have an Istio-based installation on Kubernetes, and then you can add VMs to it. There is a feature called service mesh expansion. So you can take a VM, deploy the proxy on it, make the proxy talk to the control plane on the Kubernetes cluster, and then have the VM be part of the service mesh. Yes, the control plane has to be in Kubernetes, correct. Yes. Yeah? It has a CNI. It's technically, that's a very good question. No, it doesn't. It's a layer on top of the CNI. Because it still relies on the CNI. It still relies on the fact that a pod has an IP, which is what the CNI does.
So what Cilium does is to bring them together?
It's basically, you can think about it as Cilium extended to do service mesh, except that Istio does not have a CNI. So it relies on the CNI in the cluster, and it runs on top of it. Right? Yes?
What do you think about Linkerd? Do you recommend it?
Very good question. It's actually a very good service mesh. I do have some problems with the claims they make. I looked it up just today. I looked up at their performance test for the last version, and they claim that it consumes less resources. In my experience, it hasn't been the case. When I tried it, it consumes as much resources as Istio. It's one of the things I like about Linkerd is that it comes with less features, which could be useful if you only need certain things. So for example, if you only need MTLS, I would recommend Linkerd, not Istio. Because Istio is a beast for, it can do a lot of things. And if you're only using, the MTLS part of Istio, that's basically like you're killing a bug with a bazooka. Like you're using the wrong software to solve the wrong problem. So if you only need MTLS, I would recommend looking at Linkerd. If you need all the crazy traffic management stuff, Istio is better. Make sense? Any other questions? Yes?
In your experience, what is the biggest pain with service mesh?
Debugging. Debugging is the biggest problem. Because service mesh in general, Istio has its own terminology in terms of how does it organize for example, if you are familiar with Kubernetes, in Kubernetes we have this concept of endpoints, right? So when you create a pod, it has an IP, that's an endpoint. And when you create a service that selects a bunch of pods, then there is an endpoint definition that says this IP will route traffic to these pods, whatever, right? Service mesh has the same concept, but they call them clusters and endpoints, and it's also kind of collides with the terminology in Kubernetes because there is a concept of endpoint in Kubernetes, but also a concept of endpoint in service mesh itself, in Istio. So understanding all these details of how Istio itself works, how it reasons, how when you write a policy and if it doesn't work, how do you figure out why it doesn't work? Using the istio-ctl command line is the biggest pain point in my opinion. It took me years to be able to debug service mesh. And we had a lot of problems with customers, but yeah. But I would say troubleshooting would be the biggest pain point. It's great when it works. It's a pain when it doesn't. Yes? No, it's not, because, good point. It's not, because it's not on the data path. So it only configures the proxies, but the proxies keep the configuration in memory. It becomes a problem if you want to make changes to the service mesh, but Istio D is down. Only on configuration time, not on runtime.
Scale up rapidly, then there will be a bunch of pods asking for configuration.
Very good question. Istio-D is stateless, which means you can scale it out. It actually comes with horizontal pod autoscaler pre-configured. So if you deploy it in Kubernetes and you inspect the horizontal HPA, horizontal pod autoscaler, in the Istio system namespace, which is the namespace where Istio installs the control plane, you can see that there is an HPA policy defined for Istio-D. So it can scale up and down. And there is a service in front of it, so there is a load balancer. Any other questions? Yes? You mean Istio-D, the control plane? So if you have like a multi-cluster deployment, you mean? So, very good question. I think you're talking specifically about this picture, right? There are actually many ways you can configure it. The recommended way is to have a local control plane. So you will have Istio-D in every single cluster. And then you will configure every cluster to access the other clusters. So Istio itself has a way where you can, the kubeconfig file, the kubeconfig file, which is local, that allows you to use kubectl to talk to a cluster. You can take that kubeconfig file and add it as a secret to every single cluster. So you will have to take the kubeconfig file for the EU cluster and add it to the other two clusters. And you have to do the same for everything, so that the Istio-D can use the kubeconfig file to query the other clusters. So the control plane is local, but the way you configure them with the kubeconfig and with it's called the remote config. Like you tell the Istio-D installation in EU, you tell it, OK, there is 2 remote clusters. One of them is in the US, one of them is in Japan. Here is the kubeconfig file, so you can query them. And then the Istio-D will query the kube API on the other clusters to discover the services inside that cluster. Any other questions? All right, thank you very much.